All right, math accounts, here we go. We got the factorial stretch from 2023. So here we go. So again, if you're just watching to do this, pause before I start solving the questions and see how you do. So here we go. Also, if you don't know much about factorials, go back and watch the factorial lesson. I think I just posted it at the same day that I posted this one. All right, so here we go. Factorial stretch. First of all, what's the value of 7 factorial over 6 factorial? So we talked about in the lesson that if we have 7 factorial on top and 6 factorial on the bottom, the 6, 5, 4, 3, 2, 1 in 6 factorial will take out the 6, 5, 4, 3, 2, 1 in the 7 factorial, and all we'll be left with is 7 in the numerator. So the 6 on the bottom will take out all the numbers before 7. So 7 is the only thing that we're left with. Pretty simple. All right, next one. This one's we're going to require a little bit of factoring. So this one says, what's the value of 4 factorial plus 5 factorial over 4 factorial? We cannot reduce the 4 factorials because of the plus sign up here. So these are not factors of each other. So we need to factor the numerator. So I notice in the numerator, I've got 4 factorial and 5 factorial. So what do they have in common? They all have 4 times 3 times 2 times 1 in common. So I'm going to take that out. And then 4 factorial goes into 4 factorial one time. And then 4 factorial, if it goes into 5 factorial, this one, it's like I'm dividing here. This one's going to take out everything except for the 5. So that's what the top factors into. And now what I notice is I've got 4 factorial times 1 plus 5, so that's 6. Oops, 6. Ooh, that was bad. All right, and then I've got 4 factorial on bottom. So this is 4 times 3 times 2 times 1. So is this. So they can reduce each other. I'm left with 6 as my answer. Same basic problem. We're going to do the same thing, except now we're dividing by 6. So I've got 4 factorial times 6. So I factored the top. I've got 6 in the denominator. The 6 is this time reduced. And now I'm left with 4 times 3 times 2 times 1, of course, because that's what 4 factorial is. So 4 times 3 is 12, times 2 is 24. All right, next one. If 10 times 4 times 3 is n factorial, what is the value of n? Well, you can look at it and go, okay, so this is 10 times 12, so that's 120. And if you know your factorials, you'd know that that's 5 factorial. So you might go, oh, automatically, I know the answer is 5. The other thing that you can do is break 10 into its factors. 10 is 5 times 2. So if I reorder this, I can put the 5 in front and the 2 in the back. And what do we have? 5 times 4 times 3 times 2, and of course times 1. We don't need that. So that's 5 factorial. So the 10 breaks down into a 5 and 2. I put the 5 and the 2 on the other side of the 4 and 3, and this is basically 5 factorial. So our answer is 5. Next one, if n is a positive integer, okay, so no negative numbers, and n plus 1 factorial minus n factorial is less than n to the third, what is the greatest possible value of n? All right, so this might be a problem where you just kind of start playing with the numbers a little bit. Let's see what would happen if the value was 1. So if the value of n is 1, I'd get 2 factorial here. So that's 2. And then minus 1 factorial, which is 1. And then I'd have 1 to the third power. All right, this doesn't work because I get 1 is less than 1. All right, so that doesn't work. But we want the greatest possible value that does work. Okay, so let's move on to 2. If I do 2, I get 2 plus 1 is 3. 3 factorial is 3 times 2 times 1, so that's 6. and then minus 2 factorial, which is 2, less than 2 to the third power, that's 8. Now this does work. 4 is less than 8. Okay, so 2 works. Let's move on. Try 3. 3 plus 1 is 4. 4 factorial is 4 times 6, because this was 3 factorial right there, so that's 24. And then 3 factorial is this part right here, and that's 6. And then 3 times 3 times 3, because we're doing n to the third, is 27. This works, because this is 18 is less than 27. So 3 works. So far, 3 is the greatest number that's working. We move on to 4. 4 plus 1 is 5. 5 factorial is 120. I just did 5 times that previous number right there. And then 4 factorial, we already found it out right here. That's 24. And then 4 to the third power is 64. All right, it stopped working. I've got 96 is less than 64, so that doesn't work. And I can kind of tell just by how the numbers are growing that no other answers are going to work, so 3 must be the greatest value of n. Number 16, if n factorial is the greatest factorial divisible by 10 to the 6th, but not by 10 to the 7th, what is the value of n? Okay, interesting problem. So I know that 10 to the 6th power has 6 5s and 6 2s as factors, whereas 10 to the 7th, of course, has 7 5s and 7 2s. So, if you watched my video on the lesson, we know that when we're looking at factorials, there's going to be a ton of 2s, like when we're looking at it. So, for instance, let's just look at 5 factorial. So 5 factorial, that's 5 times 4 times 3 times 2. Okay, so if I want to know how many times 10 goes into this, I need to have 1 5 and 1 2. Well, I have 1 5 and 1 2 3 2s because 4 is 2 times 2. So 2 is not a limiting factor. It's how many 5s I can get. So every time I have a 5, that will end up being a power of 10 because I can match this 5 up with another 2 to make a power of 10. Okay, so I know that 5 factorial can have 1 10 in it because 5 times one of these 3 2s. The next time that I can get another 5 from my factorials is 10 factorial. 10 factorial will have the 5, and then 10 is 2 times 5, so I can get a second 5. So I could get 2 5s there. Let's go on to 15. 15 factorial will get a third 5 from this one, because we got a 5 from the 5 here, a 5 from here, and now here's a third 5. Okay, then I move on to 20. 20 factorial has a fourth 5. So 4 10s can go into 40 factorial. Remember, we're not worrying about the 2s because there's way more 2s than 5s that we're going to find. Let's move on to the next one. 25, it's not going to be 5 5s. 25 has 2 5s in it. So I can get 2 5s here, another here, another here, another here, another here. So that's 6 5s. So 10 to the 6, oh gosh, 10 to the 6 will go into 25 factorial because I have 6 5s. Remember, it's 25 times all the numbers that come before it. So I've got 2 5s from 25, another 5 here, another 5 here, another 5 here, another 5 here. So 10 to the 6 will go into that. If I move up to the next number, now I have another 5. I now have 7 5s. So 10 to the 7th will go into this number. You might be tempted to say, oh, then my answer is 25. Because the 10 to the 6th will go into it, but 10 to the 7th won't. Because 10 to the 7th won't go into it until we get to 30 factorial. But remember, 29 factorial has all of these numbers before it. So 29 factorial, 10 to the 6th would go into it, but that would be the last factorial before 30 factorial, where 10 to the 7th does go into it. So our answer is actually 29 for this one. If you missed that, don't be hard on yourself, because I missed it the first time I did it. I wrote my answer is 25. I didn't think of going farther. Here we go. All right, how many zeros are to the right of the rightmost non-zero digit of 100? Okay, we just want to know how many zeros there are, which again means I want to know how many tens there are. Okay, so in 125, if we want to find out how many zeros are in that number, then we would want to know how many tens are, because when we multiply by 10, we get a 0, right? So it's very similar to the problem before, where we want to find out how many tens will go into 125 factorial, but we don't have to worry about the 2's. 2's we got plenty of. It's the 5's that are the limiting factor. So when I have 5 factorial, I'll have 110, 10. Like 5 factorial is 120, right? So you get 10 in there. The next factorial is 10 factorial. We would have 2 zeros in that one because we have 2 5's. Then 15. That's a third one. Then 20. That's a fourth one. When we get to 25, like the previous problem, 25 gives us 2 extra 5's. So now we're up to 6. 35 gives us another one. 40 gives us another one. 45 gives us another one. 50. 50 has 25 inside of it. So 50 doesn't just give us 1 more 5, it gives us 2 more 5's, because 50 is 2 times 25. So 50 has 2 5's in it. So now I'm up to 11 at this point. 55, that's just 1 extra 5 right there. It's because 5 times 11. So I'm at 12, 60, just 1 5 there. 65. Running out of room on this one. 70 gives me another one. 75. That's 3 times 25. So I've got 2 5's inside of 75. So now we're up to, what are we up to? 17. Then 80. That gives me 1 more. 18. 85 gives me 1 more. 19. 90 gives me 1 more. 20. 195 gives me another one. There's 21. 100. 100 is 4 times 25, so I get 2 5's out of that one. So that's going to be 23. Almost there. 105, that gives me another 5. That would be 24. 110 gives me another 5. 25 5 so far. And 115 gives me another 5. 26 5's. 120 gives me another 5. 27 5's. And then on, I missed one. Where did I miss one at? I'll go back and count them. 125. 125 is 5 times 5 times 5, so we get 3 5's here. I miscounted somewhere. Well, I'll recount in a second here. So I'm saying 30. I know my answer is 31 because I already did this problem. Here, I'll pull over my work from my previous problem when I did it the first time. All right, so on this one, 5 gives us 1, 10 gives us 1, so 1, 2, 3, 4, 25 gives us 2. trying to cover up the answers for next problems. So there I'm 1, 2, 3, 4, 5, 6 for 25, 7, 8, 9, 10, 11, 12 for 50, 13, 14, 15, 16, 17, 18 for 75, 19, 20, 21, 22, 23, 24 for 100, 25, 26, 27, 28, 29, 30, 31. I don't know how I miscounted on this one. We have 31. How did I miscount? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29. Or did I miss it? 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 60, 60, 70. I don't know where I miscounted. Whatever. Maybe you see it. I can't tell where I miscounted. Oh well. I'm bad at counting. Counting's hard. All right, next one. What is the greatest prime divisor of 11 factorial minus 10 factorial over 6 factorial minus 5 factorial? I don't know. Let's find out. So for this one, I'm going to factor out the top. So I'm going to factor that into 10 factorial times 11 minus 1. And then in the denominator, I've got 5 factorial times 6 minus 1. So the numerator, I have 10 factorial over, or times 10 over 5 factorial, and then 5. All right, so let's just start reducing this. 5 goes into 10 twice. 5 factorial goes into 10 factorial. And I'm left with 10 times 9 times 8 times 7 times 6. All right, so here's what I've got. 10 times 9 times 8 times 7 times 6, because the 5 factorial took out the 5, 4, 3, 2, 1, and I have a 2. I want the largest prime factorial, or divisor. Well, there it is right there, 7. 7 is the biggest prime number that will go into this number. I can just tell by looking at the factors. 7 is the biggest prime factor of that number. I don't need to multiply it. I can just look at the factors and find the biggest prime factor of those. So my answer is 7. How many divisors of 4 factorial times 3 factorial times 2 factorial times 1 factorial are perfect squares? All right, so I'm going to have 1 4, 1 2 3s. I'm going to have 1 2 3 2s. See how I did that? The 4 factorial is 4 3 2. The 3 factorial is 3 2. The 2 factorial is 2. We can even break it down that this is 2 more 2s. So I've got 3 times 3, and then I've got 1 2 3 2s and another 2 2s there. So I've got 5 2s. All right, we want divisors, so let's just start with the smallest perfect square divisor. 1 definitely goes into that number. The next perfect square is 4. Yes, we have 2 times 2, so 4 is going to go in there. The next one is 9. We have 3 times 3, so 9 is going to go in there. Next one would be 16. 2 times 2 times 2 times 2, 4 2s, that's going to work. Next one would be 25. I don't have any 5s here, so 25 can't go into there. Next one's 36. 36 is going to work because I've got 3 times 2 here and another 3 times 2 here. So I do have 6 times 6 in there. 49 is not going to work because I don't have any 7s. 64, 1, 2, no, that's 32. So 64 is not going to go in there. 81 is not going to go in there. I don't have enough 3s. 100, I don't have any 5s, so that's not going to work. 121, that's not going to work because I don't have any 11s up there. What about, 144. 12 times 12. these three numbers make 112. And then these numbers over here make a second 12. So that's 12 times 12. And I think that's going to be the last one because I only have a 2 left over. There's no way that I can get any bigger there. So those look like all the perfect squares. There are 1, 2, 3, 4, 5, 6 of those perfect square divisors that would work. All right, last one. How many positive integers where n is less than or equal to 25, so any number from 1 to 25 that's an integer, are there for which n squared is a factor of n factorial? So what we're really looking for is, do we have any ones where n squared can go into n factorial? Well, the first one that would work would be 1, because 1 over 1, that works. Okay, so there's our first one that works. 2 is not going to work. 2 over 2 squared, there's too many 2's down here. It's not going to work. So 2 doesn't work. 3 does not work because we've got 3 times 2 times 1, and then this one has 2 3's on the bottom, so that's not going to work. In fact, all of our prime numbers are not going to work. Think about it. If I've got 7 factorial, there's only 1 7 up there. And this is 2 7s, so it's not going to go into it. Or take 11 factorial. 11 factorial, 11 times 10 times 9, we're only going to have 1 11 there. So 11 squared couldn't go into it. So any of our prime numbers are not going to work. So it might be easier on this one to just write down the numbers that don't work. The prime numbers from 25 and below would be 2, 3, 5, 7, 11, 13, 17, 19, 23. Now you may be tempted just to look at those, but sometimes smaller numbers have some problems with them. And in this case, we do have one more that is not a prime number that does not work, and that would be 4. If we've got 4 factorial, that's 4 times 3 times 2 times 1. And then this is 4 squared. 4 squared has 2 times 2 times 2 times 2. But 4 factorial only has 4 times 3 times 2. That only has 1, 2, 3 2's. So 4 2's can't go into that. So that's not going to work. So 4 is another one that's not going to work. But once I get to 6, then it starts working for our non-prime numbers. Like if I got 6 factorial, within 6 factorial, I can find a second 6. Because 6 factorial would be 6 times 5 times 4 times 3 times 2. So I could get 1 6 from here, and I could get a second 6 from here. Everything after 4, every non-prime number after 4, we're going to be able to find factors below the number that comprise the bigger number. So it's everything except for 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's everything except for those 10 numbers. So how many numbers do we have left? 15. 15 integers would work because 10 integers don't work. The end. All right, keep mathing hard. I will see you later. Bye-bye.